Hey everybody, my name is Gil. I'm a software engineer and also a team lead at Wix. Today I want to talk about how we improved the performance of millions of Wix websites. For a long time, performance was the biggest issue for our users. And in the last 2 years, we invested a lot of effort to improve the user experience. So I want to tell you all about the journey that we went through, the performance issues that we had and why we had them, how we fixed them, and also how you can implement those improvements in your web application and also in Velo. So you're probably wondering how much we improved. Take a look at this graph for a second. This is a graph based on Core Web Vitals. Core Web Vitals is a metric that Google developed to measure the user experience of websites on the internet. And we use Core Web Vitals to measure our web application. I'll explain in a second why. You can see Wix in the orange graph versus other web platforms, our competitors, and you can see how much we improved from having very low Core Web Vitals results to having one of the best in a relatively short period of time. Before I dive into how we improved, I want to take a minute and explain why we use Core Web Vitals. You probably know that in order to write good applications, you need to first measure yourself, monitor your improvement, and compare yourself against your competitors. But how and what you measure is extremely important. You've probably seen this page before if you develop web application. It's a screenshot of page speed insight, which display the Core Web Vitals data. There are actually multiple ways to measure using page speed insights. You get the field data and the lab data, and it's important to differentiate between those two. So field data measures the user experience in production with events that are sent from production, and lab data measures the user experience in a simulated device or and simulated network. So, for example, like a low-end device with low internet connection. And we started using lab data back then, but we very quickly moved to field data and measured the user experience from production. And actually, there's a big difference between those two. Again, like I said, Core Web Vitals measure the real user experience in production, unlike the lab data. And in the lab data, you might miss a lot of issues that you have, or you might be optimizing for issues that you don't have. It really depends on your users. This is why it's very important to use Core Web Vitals, because again, it measures your user experience in production, what your users are really feeling and experiencing. And also, it's very important to use Core Web Vitals because Google announced that they are using Core Web Vitals to rank SEO. And it's very important also for us and also for our users that Wix websites will have a very good SEO ranking and SEO scores. And also, obviously, impacts our brand. I didn't mention it, but my name is Gil. I'm from the Wix viewer team. In the viewer team, we develop the application that renders and displays Wix websites. Since we developed the main application, we have a lot of impact on performance and Wix websites, but not all the impact. It is important to mention that I was in the platform team, and in the platform team, we actually developed the capability to extend the Wix website. So so we enable developers also in Wix and also outside of Wix to extend the functionality of Wix websites. And Velo is a good example that our users can actually extend the capabilities of their websites with code that they write, and we are running their code in our application. So this is why we don't have all the impact on performance, but since we are the host application, we have most of the impact. So going back to this graph, when we investigated why we have all those performance issues, we realized that those issues were not that small, actually quite big, and required a drastic infrastructure change. This was not a one-line fix. So we started a huge project to rewrite our entire web application from scratch in order to create the best performing web application possible. Today, I want to tell you those big changes that we made. I want to tell you why we made them, what were those big issues that I talked about, and how we implemented them. it is important for me to say that both those issues and solutions are not unique to Wix. I think that you can find those issues in a lot of other web applications today on the web, especially web applications that have performance issues. And also those solutions could be implemented in any web application today in the web, and also in Velo, and I'm going to talk about it later in the talk. So I'm gonna begin with talking about the performance problem. I'm gonna give an example of a feature that we have that caused a performance issue. I'm going to talk about how we fixed it, what was the specific solution, and also the solution for our entire application, the design that we chose. And also then I'm going to talk about how you can implement the same solutions in Velo and in any other web application if you have one. And I'm going to talk about future plans and what we plan for the future in terms of performance. So there are many ways to improve user experience and also core vitals. There are actually a lot of things you can do, and unfortunately, I don't have enough time to talk about all of them. So I chose in this talk to talk about the thing with the most impact. There are a lot of things, and you don't even bother going on this list that you can do. There are a lot of issues that you can have and a lot of solutions, but most of them are small fixes with small impact. And I chose the thing from my experience, the thing that solution with the biggest impact. So, and it's the JavaScript download size, and I'm going to talk about it right now. So JavaScript download size. I want to explain what I mean by that. So if you go to the network tab in the Chrome DevTools, you can see how much JavaScript you download in a website. Obviously, we all know that in order to write web applications, you need to run JavaScript in the browser, and you can see how much you download in the bottom of the network tab. You can see in this example, 3.2 was actually downloaded. Most of the time it's compressed, and then the browser uncompress it, and then it ends up with, in this case, almost 15 megabytes of JavaScript resources that he then needs to parse and some of it run, which also slows down the application. So it's important to also differentiate between those two, transfer size and resource size, and also to take into account that you also need to download JavaScript size, parse the resources, and then run some of them. So how come JavaScript size become a problem? And I want to give you an example of a feature, one of the most popular features we have. It's the button example and the link feature inside the button component. So take a look at this panel. It's the link panel. And in this panel, you can choose to which page you want to navigate when your user click the button. So for example, in this use case, I chose that when the user clicks the button, it will navigate to the home page in the current window. And you can choose any other type of navigation. You can also choose to navigate to a web address or to the top or bottom of the page. You can open an email or a phone number or a light box, which basically just a pop-up. There are many types of things you can do when the user clicks the button, and you as a user can choose any one of them. So if you were the developer that gets this feature, can you imagine how would you implement it? I want to go over a naive implementation and talk about some issues that maybe come up with this naive implementation of this specific feature. So when the user enters the properties of the link panel, the most obvious thing is to save it in the database, right? If the user does something that you need to save and use it later, you probably need to save it. So you save it in the database. And let's take a look on an example of the data that is saved. This is the saved data that we actually save in the database. So each button will probably have an ID, a type, the type, because you have more components and you want to differentiate between those components. And the data of the button is going to have the label, which in this case is click me, and then the link object, which includes which type of link the user chose in this in the panel, and also the page ID where the navigation is going to. And in case he chose a web address, maybe you would need to add the URL of the address. If he chose phone number, obviously you need the data of the phone number. So, but in this case, the user chose a different page, so we need to save the page ID. And now this data needs to be passed into the component. When the user opens the URL, we need to get this data and render the component. So let's take a look on a simple button component that gets a props and need to return the HTML. So in our case, the button takes the link object that we just saw, and now we need to render the HTML. In our case, an anchor component with an anchor element with an href, because you need to perform a navigation. So we need to calculate the link of this link type, link object. We'll see it in just a second, and return the href. And it's very important to also return a regular button in case we don't have a link. It's very important for SEO reasons that we will render an href only when there's a navigation, and a regular button when there's no navigation, just a button that you can interact with the web page. So this is the simple React component that creates the HTML from the data that we got. Now, this is kind of how it looks like when you look on the flow from the user. When he creates the panel, we save the data, and then we send the data to the client side. We calculate the link using the code we just saw with the React component, and we calculate the HTML. And let's dive into this calculate link function that needs to return the href that we actually put in on the HTML. So it gets all this data that we saw earlier, and now it needs to return the href, right? So, but it really depends which type of navigation or which type of link the user chose. The user, if you remember back in the panel, the user was able to choose different types of navigation, and we need to calculate the href based on the type of this link. So going back to the code of the calculate link function, for each type of navigation, we need to choose the right href to calculate. So this is a pretty naive example. So this is a pretty naive example. I want to go over the main solution, but honestly, it's not very different from the solution that we had before, because it's a very common practice in web applications. When the user enters data, you save it, and when you need to display it, you send it to the client side, and you calculate the HTML either using React or any other framework. And if the user had options, you put all the options in the JavaScript that you ship to the client side, and then you just run which option that the user chose. So why is it a problem? Because many options cause components to download a lot of unused code. And let's look at these unused codes. First of all, the calculate link function. And we only ran one line of code, but we had to download all the different options of code. And all this code is unused. And this unused code is, like we said, is downloaded and needs to also be parsed, but not run. So in case we didn't, and the thing is that the user can only choose one option. So in most sites, most of the code of this function is unused. And also the code that here we have more unused code. As you can see, the button that needs to be rendered is also unused. And it doesn't matter which option was selected, right? Because the user can choose only one option. And so this is the first problem, the amount of unused code that we download because users have different options to render the component. And since we want to give them all the options that they need, we ended up with a lot of unused code. And the second problem is actually the resolving code, the code that transforms the saved data to the view data that is downloaded, but then executed in the client side, which results in low core vitals. We talked about that before. So let's look at this. Let's look at this code. We mean the actually code that's running. So it's in this example, it seems like not a lot of code, but imagine if we had a big logic that needs to calculate, more logic that needs to be calculated to the HTML, we would need to download and run a lot of code. So a question that comes up, and maybe or you're already asking yourself this question, is why do you need to calculate the data instead of saving it? Why not just save the data the way that you want to show it, like displayed in the HTML? And it means just basically save href when the user save the site or actually edit this panel. And the answer is because you will move the issue to the editor side. If you will save the data, we will remove, actually save the href when the user choose which type of navigation he wants to do, then we will need to do all this calculation in the editor side. And then it will be hard for us to display this panel. Actually, the data that we saved before was actually perfect for this panel, but it's not good when you want to actually render the site, because then you need to calculate HTML. So we want to have the saved data the way we saved it earlier to display this panel, but then we also want to calculate it in order to display the HTML, but we don't want to calculate it in the browser. So how we solve this? How we solve this solution? So how we solve this problem? So the first thing you need to do to reduce JavaScript download bundle size is to not download all the unused code. You want to download smaller components. So instead of this big button component, you want to rewrite your component into small feature-specific component, like link button. If you had many types of navigations, maybe you need different types of components for each navigation type that the user chose. So instead of downloading one big button with all the options, we can split the button into small feature-specific components, and then just render the one that is actually used, and also download the one that is actually used. So this is the example of the big button component is split it into link button, which only renders an href, and a regular button that only downloads and renders a button. And then I can choose which one I want to download, and then run only the button that is actually used. And you can see that the href is already calculated in the prop. So how come and where did I calculate the href, and where did I choose which button to download? So the second solution, or the second half of the solution, is instead of calculating view data on the client, we want to calculate the view data in a server, and in what we call a front-end server. So we could take the JavaScript that was used to calculate the HTML from the saved data, and we can just take it as is and run it in the client side. So imagine this calculate link function could actually be written inside our servers, because there's nothing to do with, it has nothing to do with the browser. It basically takes data and return view data that we just we then take and transform it to HTML. So let's see how it looks like. So before we save the data from the panel and we send the saved data to the client side, we then shipped a lot of JavaScript to parse, to actually transform the saved data to view data to calculate the HTML. And if you remember, also this JavaScript included a lot of unused code because of the amount of options we had. So now the panel is still saving the data in the same backend server, but it is sent to the frontend server and not to the client side. The frontend server actually take this saved data and transform it to view data using the JavaScript that was then sent to the client. Now is actually stored in the frontend servers. Doesn't cost us anything because it's stored in the server. And then when we transfer view data to the client side, first of all, this view data is much smaller than the stored data, but then we need way less JavaScript to transform it to HTML because it looks exactly like the HTML. And because we saved the data we calculate the data in the front-end server, now we can use CDN caching. We can cache the result of this calculation, and then the first time we save it to the cache, and then the second time we get the result from the cache. So because before that we couldn't do it because we used to calculate the data in the client side. We couldn't save it in the client side. But now because we calculate in the front-end server, we can actually save it in CDN cache. And then the second time the user goes into the same website, we just immediately get the view data from the cache. So we don't even run the code that was previously ran in every render of the website. So the component gets the view data super fast, calculates it easily because it's very similar to the HTML, and returns the HTML. So let's take a look at the example we had. Again, we had data, we had saved data, we have this calculate function that just need to transform this data to view data, and then we take this data, and this is very similar to our HTML. So it's going to be very easy for our client side we don't need a lot of JavaScript to transform this object into the HTML that we saw before. It's easy, and now I want to say that it's a small example. It's an example of one feature of one component, but as you probably know, we have in Wix many components, each one with a lot of features, and by applying this solution in all of our features of all of our components, we saved a lot of code. We moved a lot of code away from the client side to the backend. Also code that was unused. We removed a lot of unused code from the client side. And now when we ship code to the client side, we ship only used code and all used components. And also when not running, we don't need to run a lot of the code that was running on the client side. We actually run from the server side. So both of those optimizations were huge when we did them for all our components and all our features as well. So one small example, if you implement it in all of your components, has a huge impact. So you probably ask yourself, can you do it in Velo? And the answer is yes, you can do it in Velo. And I want to show you how. So I want to open the editor, and I want to go into the product page that I implemented, and let's look at the code that I implemented here in Velo. 1 second. So imagine that you have a product page, and you want to implement a simple feature called suggested items. So you're going to this is the onReady function where you write the client-side code. So we're going to use Wix data to get the products from the backend. We're going to get the orders from a different collection. And then we're going to calculate suggested items based on the products in the orders. We're going to do something like choose the products that are similar based on the orders of the users. And we're going to take these suggested items and add it to some suggested items repeaters that we have here below. And this calculate suggested items function takes the product and the orders and calculate it best based on the products and the orders and return some array of products. So you can probably imagine what my solution is going to be like. And also you can imagine the issues with this code. Also, I need to get all the products. I need to get all the orders. I need to send the data to the client side. I need to do this calculation that maybe is not efficient because it iterates a lot of might be big data structures. And I need to also download all this code, obviously a small example, but in real world, the examples probably way bigger. I need to download this code to the client side. So how do I fix it? I move it to the server side. So you can create backend files here, backend files in Velo. So I open my suggested items file that I created here, and the only thing that I need to do is basically just copy or actually cut this function and paste it in my backend file. I could also copy the Wix data queries to the backend file, and I can implement those right here. So I can do all of the things that I used to do in the client side, I can do them in the backend. And then I simply call this function. In the client side. I don't need the products in the orders because I can get them in the client side. And I just import this function. I import this function from my backend file. And I know it sounds like I import this file, and you probably are wondering, how can you import a file from the backend in the client? But the truth is that under the hood, there is actually an API call that is sent when you call a function from a backend file. So there's actually an API call to get the data, and this is not a regular function. This is not a regular function. This is actually an API call. So this is how you can implement the same solution in Velo. And you can implement the same solution in any other web application. If you have code that is not based on the browser, on the environment of the browser, it's basically just take data from the server side and transform it into something that you then render. You can just go to the server side and you can call it from the client side. So you remove all this code that is downloaded, and also you don't need to run it. So again, going over the Velo example, before that, I used to send all the data from the backend, from the Velo collection to the client side, and use $W to update the HTML. And now I just put the front-end server in the middle and put all the logic in the Velo, all the business logic in the front-end server, and then I send just the data to the client application to update the HTML. So a little bit about some challenges that we came across when we finished implementing those solutions that I talked about. There are actually new challenges that we found out that actually causing some issues in our application. It definitely improved, made a drastic improvement in our application, and you can see it in those graphs, but brought new challenges that we now need to solve. And the first challenge is actually the cache invalidations, because now when we are using caching, now the data is cached, and when you use caching, in most cases, you're running into invalidations issues. It's the issues that the cache is invalid, but you don't know about it. So one example would be if you cache a product price, but the price changed, you need to invalidate the cache. So, and maybe it was better, and if the price changes all the time or very frequently, now you never use the cache. You always invalidate the cache, and then you always need to calculate the cache over and over again. So maybe it was better not even cache it in the first place, because then you can just remove. Maybe sometimes we find out that sometimes it's better to not cache some values and calculate them in the client side, but actually and then keep the cache alive for more time. So if we find out there's something that invalidates the cache frequently, we basically just calculate it in the client side instead. So this is kind of like a trade-off, and you need to be aware of what you are calculating inside the front-end server if you're using caching. This is very important. Another challenge that we faced when we moved to the new architecture is that now, since we splitted our code into small feature-specific component, like I talked to you about in the beginning, now we have many small files. So imagine a big site with a lot of components. If in the beginning, let's say a file with a lot of buttons, which is it makes sense, and if before we had a one button component, now we have many small feature-specific button component. So now we have a lot of small files, small JavaScript files. If you have a lot of small JavaScript files, there is a trade-off between how much you want to split, because each JavaScript file actually creates an overhead of the request, and also the compressing is not good enough. So now you ended up with a different problem. So it's not, so in most cases, it is good to split components, but sometimes you need, if you split too much, you're gonna have a problem. Now we're playing with some solutions regarding this new challenge that we are facing. And one of the solutions is actually a bundle using a bundle tool, a build tool like Webpack. You can split as much as you want in the source code, but then have a configuration that bundles the files with your own logic. And in our case, the logic is that you want to bundle components if they are downloaded in the same pages frequently. So for example, if button and image or a specific button feature, two specific button features are always downloaded together, I want to bundle them together. And we use BI data to calculate which features and which components are downloaded together, and then we make those bundles when we build our application. So this is also a technique that it's going to help with this new small JavaScript files challenge. And the third challenge that we also tackled and also solved is splitting large components with shared logic. So my example of the button is it works for many components, a lot of like button, like image, like the text component. But for big components, such as, like, for example, if you think about a product page that has a rating button inside, a rating component inside it, and comments component inside it, it's gonna be challenging to split this large component into small feature-specific components, because then you're gonna have product page with rating, product page with comments, and all the permutations. So it's not that easy to split these large components with shared logic, especially when they have shared logic. And so I want to talk a little bit about the future plans that we are going to have. So one future plan is, like I said, treat the cache invalidations the right way. And we are playing with a few ideas how to best treat cache invalidations also automatically. But in most cases, it would be just to make sure that we are not caching. We are not caching data that is invalidated very frequently. Maybe it's better just to move it to the client side. We need to find a balance of size and amount of JavaScript files, and also, like I said, build a solution that bundles components that are downloaded together frequently. This is what we are currently working on. And also find how to split large component with shared logic. I talked about this. There are actually a few libraries out there that also are integrated with React that helps with that, and we are investigating what's the best solution. I want to go back to this graph because this is probably the most important data that I showed you. It's how those solutions improved the performance of Wix websites. And those new challenges are actually just the solutions for these new challenges are going to make us even improve more in the future. So the big takeaways is that the best way to improve loading time is to decrease the amount of JavaScript downloaded to the client, and also the amount of JavaScript that is actually executed in the client side. So you can do it by moving logic from the client side to the server side. You can, like we talked about, you can do it also in any web application. You can do it in Velo. Writing small feature-specific components. We talked about how the big button component was included a lot of unused code, and writing those small feature-specific components and downloading only those feature-specific component is definitely gonna make your application download less JavaScript. Caching servers responses in CDN was a huge improvement for us, because in a lot of cases, in a lot of sites, we don't even run this code that we used to run in the client side back then. And of course, one of the most important thing is that you can do it in Velo, and I encourage you to try it. Think about take a look in your application, either in Velo or in any other web application. Where is the code that you can actually extract and move to the server side, and see how much code you can remove. Also download code, also download less code, but also execute less code, and you can check caching options. There are many ways to cache server responses today in the internet. Thank you very much. I hope you enjoyed it.